Okay, welcome back to this section 6.1 video. And in this video, we're going to recap the ratio test that you should learn when in Calculus 2, trying to see whether a series converges or diverges. And so for this differential equations course and for these power series topics, we're just only going to be looking at the ratio test for convergence. All right, so we're going to keep it simple. Okay, we're going to keep it simple. Just use a ratio test. You don't have to worry about all the other tests you might have learned in Calc 2 for this component. And so, what do we use a ratio test for? Because we want to know for what values of x a power series converges. Okay, so here's a ratio test right here. Here's a bit of a recap for it. So consider the power series Cn times x minus a to the n. Convergence for a power series can be determined by evaluating the following limit. So we take the limit, the numerator is n plus 1 terms, and the denominator is just a regular original n terms. We take out the center, x minus a, and so we're just left with that times the limit of your constants. Um, and that's kind of the idea. So limit, if the limit is less than 1, the power series converges absolutely. If the limit is greater than 1, the power series diverges. If the limit is 1, the test is inconclusive. Okay, so that's how the ratio test works. All right. Um, you know, with the ratio test comes interval and radius of convergence. Okay. So when we find the limit, we set it less than 1. Because we're trying to find out where a power series converges. So we know we converge for the limit less than 1, so we set it less than 1 and trying to see what x values give us that convergence. So we'll have to do some algebra, move a couple of things over, deal with some inequalities. But yeah, so essentially we're just setting this ratio test setup less than 1. And so wherever that absolute value of x minus a interval goes, that's what we'll get the interval of convergence. Okay, so we have the absolute value of x minus a less than r. And so the way we work this is we drop the absolute value, and what we would have is x minus a between r and then negative r. Okay, but we want to find the values where x converges. That's what we're looking for. And so what we're going to do is just add a to both sides. That'll get rid of the a here. And so what we're left with using some algebra is a plus r less than x less than r plus a. Or maybe to keep it consistent, we'll say a plus r. Okay, so that's our interval of convergence. Okay, so that's us looking at this, using the ratio test and using some algebra, but what does this look like visually? So consider this, your number line of x values, right? Here is A, your center. Okay, and then here is the value of A minus R. Here's the value of A plus R, right? You're subtracting the radius from A, you're adding the radius from A. Well, from A minus R to A plus R, that's our interval of convergence. Okay, so that's what we're saying. All of these x values from here to here are within our interval of convergence for our power series. Okay, then one last thing to talk about is the radius of convergence. And what that is just the half length of the interval of convergence. Think about it like a circle, right? The radius is just half the distance from the middle to the edge. So, I would say like from here to here is the radius of convergence. Okay, and then A is your center, just to make sure we're clear on that. But yeah, so that's the setup with the ratio test and using it for interval and radius of convergence. Luckily, we just need to use a ratio test for these problems and just keep it a bit simple, okay? So that's it for this video. We're going to try out an example in the next one, but I'll see you there. Take care.